Let's look at the equilibrium question that we have on screen. It reads, the plane truss uh, is shown in figure 3 of this figure 3 that I didn't show it here. Figure 3. Um, Pin supported at B. Here at B it is pin supported. Um, if it pin supported, by now you should know that that means that it can rotate. It can rotate either way. If it rotates, if we're saying it can rotate, we mean there won't be any torque reaction, or should I say moment reaction. So is pinned at B and the roller at C, and there is a load of 10 kilonewtons they applied at point A. So first thing we need to do, we need to identify the reactions. Okay, here it's a pin. Obviously there will be a reaction. We'll call it bx. Okay, my x was bad, x, and there will also be a reaction this way, and I will call it by. You can decide to call it whatever you wish to call it. And here it's a roller, right? A roller can move along the plane where wheels are. So that means the roller can move along the y. So there will be no reaction along the y, but they only gonna be a normal reaction perpendicular to the surface. Rollers have normal reaction. So I will call it Cx. I'll just level all my forces here. I'll have force P, of which is just, I'm writing exactly what is there, kilonewtons. Okay, so for equilibrium questions, you know that you're always going to have your equilibrium equations, of which are your sum of forces along y along x equals to 0, and you also have sum of forces along y should also equals to 0, because this thing is steady, it's not moving, right? It's not accelerating, let me say it like this, because we know that from F net is equals to ma, your Newton second, your acceleration should be 0. Then if its acceleration is 0, it will be more. From more, you will have o, right? Ma, more, o. Ma, acceleration is there. If acceleration is 0, then it changes to more. If it's more, it changes to o. That means sum of all forces is equal to 0, which that's where we are right now. So what else we need to look at? We need to look at, let's go back here on our diagram. Look at all the forces along y-axis. Okay, I didn't choose direction so far. It's a very bad habit, and to choose it this way is positive. Also downward is positive. Also clockwise is positive. So now you have your directions. You can do your math. So sum of forces along the x, sum of forces along the x, all forces that are horizontal, right? We have bx there. We have bx is this way, is toward left, then it's going to be positive according to our direction choices, and cx is also this way, it's going to be positive again. Any forces? Obviously no, equals to 0. Okay, that's all we can have here. Let's look at sum of forces along y. Along y, we said down is positive, and from down we can see that we have force P1, or the load of which is just 10 kilonewtons downward of it. That's why it's positive. And we also have another force By, of which is also positive. Do we have another force? We have already recorded By, we have no y here, we have only y here. Then that also should equals to 0. From here we can get our By to equals to negative 10 kilonewtons, right? negative 10 kilo newton. Okay, your equilibrium equation is not only this one and two. You have the third one. What is it? You know it. You just said it. Yeah, it's correct. Sum of moments. Okay, should also equals to zero. Okay, so let's look at our diagram. So when you take your moments, it's always up to you. There is no rule where you should exactly take your moments, but normally you should normalize taking them where there are a lot of forces to eliminate a lot of problems for you. So you don't want problems, right? So choose where there are more forces, less problems. Okay, I choose to take uh my moment around B, should I say about point B. So I'm just going to look at the moment, or should I say the torque caused by this force. And then I have the distance. Remember, what is your moment? Your moment is equal to the force and the arm. The arm is at the distance. Force by arm, that is your torque or your moment. Okay. So now let me just put 0 here. Moment caused by this one is going to be 10 kilonewtons, obviously, and the arm, perpendicular arm to be specific, of which for that for 10 kilonewtons you're going to have 2 meters. Okay, and this one is going anti-clockwise. It's supposed to be negative according to our directional choice. And let's look at another moment. Let's look at cx. Cx is going in this way, clockwise. That should be positive cx. And what is the arm? It's also 2. Okay, and that is equals to 0. Right? Okay, we're still good. And from here, uh, if you could notice, we have this 2 and another 2 here. Because they're equated to 0, it's more of like taking out its common factor and dividing by 2 both sides, of which is just simply, I'm trying to say to you, just eliminate this and this. You can choose not to, but you'll see, you'll just divide by it and it will vanish. So just remove both of those and you will transpose this one to be negative 10, which was negative, now it's going to be positive kilonewtons, and here we're left with Cx. Now you have Cx. If you have Cx, here we're just missing with Cx. If we can get Cx, we can get Bx. So we just say plus Cx, the 6 we just got now is going to be 10 kilonewtons is equals to 0, and then we have bx here, and then from here we can again transpose to the other side. We have our b bx is equals to negative 10 kilonewtons. Okay, so we got c. You already got c. We've got c. We just got c here. Cx is here. Is here. We also got bx. Oh, we also have by here. So we've got all the support reactions at joint B, C in kilonewtons, and report all your values in 2 decimal places. So just because I didn't listen, I always am going to fade. Obviously, if somebody was marking my work, I think you're supposed to write like this. Kilonewtons. You're just going to put zeros all over your answers because you want to pass, right? So don't be like me. Put these ones, just listen to your instruction. 2 decimal places in kilonewtons, that I was able to do that. BC, I did that. So the second part of the question, they said solve the forces in member AB. This is the member AB they're referring to. And also they said and in BC, this is BC in kilonewtons again. Indicate for each member if the member is going under tension or compression. Okay, if intention, only write T in the space provided, and if it is a compression, write C the space provided. It was a test question. Report all your values in two decimal places. I need to highlight that so that I don't do that mistake again. Okay, so let's look at this thing like in points. Let's look at point A. That's this. Let's say this is our point A. Point A here has a force here called, or should I say, with a magnitude 10 kilonewtons. Okay, and we have a beam. This is a beam AC. Okay, so if you can just look very carefully, if I can finish up this circle, this shape, we just called it. Just fill the circle so that it will make sense. I keep calling it the circle, the square. So we have 2 by 2 by 2 by 2. That simply means that this side here is equal to this side, also equals to this side, also equals to this side, and we could have another diagonal going here. That diagonal will be equal to this one, also equal to this one, also equal to this one, and this angle is going to be 90, and this part is going to be 45, and this one is going to be 45 again. So this is strictly a square. We just saw that because it has same size, 2 by 2. So we can adapt most of all the square features to solve the problem. What do I mean about all the square features? The only thing that I literally wanted, I only wanted to show that here we have 45 here. If we have 45 here, we can get the force that is on the beam. If we have 45 here, that was my point of doing all the square thing. So with this as an adjacent, you can get this one as a hypotenuse, right? You could just say this is adjacent, right? It should be cos 45 should equals to adjacent, of which we know in our case kilonewtons all over hypotenuse, of which is just force on AC. Then I cross multiply very well, then I will have my force that AC is equals to 10 kilonewtons all over cos 45. Then you can do your math, do your computation very well. If worked very well with your calculator, you should get an answer of 14.14 kilonewtons. Remember, they said we should report our answers in two decimal places. I don't know where they said it, or we just obeyed that. And also, they said we should report it in kilonewtons of it. That's what I just did. If we have this force of 14 kilonewton going this way, 14.4, okay, whatever I'm trying to write, but it was supposed to be 14.4 kilonewtons pushing this way, there will be a reaction again. So whenever there's a force pushing toward the beam, that means that that beam will be going through compression. It will be compressed in. So because one of the questions they said we should indicate if it's go through compression, then we're writing C for compression. It's being compressed this way. There's a force pushing this way and another force pushing this way. So this beam is being compressed. Okay, let's look at the beam AB. AB is this way. AB. This is B, there is point A that we're looking everything at, and this is point C. Okay, so the very same force that is here, of which is 1414, and we also did mention that here and again, because this is actually to complement this to make it 90, it has to be 45 degrees again. So we have this 45, we want to get this side. We'll do your math again, of which it's going to be, now you have the hypotenuse, right? So it's going to be, you and the adjacent is going to be cos 45 is equals to the adjacent that you're looking for, of which is force AB all over hypotenuse, of which is 14. Then you can do cross multiplying and force AB again. If you did your computation very well, it should give back to 10 kilonewton. Now we have to decide if this force is going this way or this way to help us decide if this beam is under compression or tension. But the answer that we got here was positive. If we reflect back in the beginning of the video, we made a choice that everything going this side is positive, right? So now that means that force is going that side. It is going this side. If it's still going this side, obviously the reaction will go the other side, and then this beam AB is going to go under tension. It will be pulled both sides, and along it that will be tension force that it will be feeling. We can go through another point. We just did A. We were just focused on point A. You can go to another point for B. You can go to another point C. But it is on this problem of ours, it's kind of irrelevant to do this and do this and do this, while this is a square. Whatever you do here, whatever anything you do here is the same as what you have done here. Is the same as here. Is the same even here. I don't even know if there's anything there, but because it's a square, it's everything is the same. It's symmetrical. It's all the features. You don't need to do stuff twice. So this repeats for any other point. I just focused on point A for my solution purpose. I did point A, and it just tells me that point A is the same as any other point in this system because this is just a square. So whatever A fills, every point fills that way. So thank you for watching, and hope you find this video informative and helping toward your studies. And please don't forget to thumbs up if you feel like the video you want to see most of videos like this one, maybe in this topic, and you can also comment if there is any topic that you want us to touch. Most importantly, don't forget to subscribe. Let's just give you 5 minutes too. Thank you for subscribing again, and share the video with your classmate.